I would now like to invite Professor Gautam Desiraju ji for his talk.
Respected Professor Murli Manohar ji, dear Jayant Sahasrabuddhe ji, Shri Bhavesh Kansara ji, the Atharva Foundation, ladies and gentlemen, I have great pleasure in talking to you this evening, Abhi sun raha hai, on the topic of Indian thought streams as it relates to modern research in STEM subjects. Shri Jayant ji has given an admirable historical roundup of the damage inflicted on the Indian mind in the 2.5 centuries of colonial rule. My plan for this talk is to touch upon philosophical and epistemological concerns that concern these Indian thought streams. In order to do this, I will speak very briefly about the rise of reductionism in the West, because that is where the story sort of begins for us. It is not my intention to speak about the things that were done in India in the distant past. Even some of the small pieces of evidence we see now, we realize that there were tremendous things going on. But be that as it may, the period of the Renaissance started a fundamental way in which we started thinking about science. And that model for doing science continues till today. And all of us all over the world who are doing science, somehow or the other, adhere to those principles of reductionism that were put in place first through the work of Copernicus, then of course Galileo, mechanics, then Newton, and then as we go along a little later to Robert Boyle, Charles Darwin, of course. So the idea of cause and effect, that effect is determined by cause, cause to effect, this one-to-one correspondence between cause and effect, I think is the bedrock of Western science. Why did it work so well? It did work very well, no doubt about it. I mean, we can talk about the laws of electromagnetic induction, Faraday. Even the quantum theory was all absorbed into this overall scheme, although it was looking little fuzzy. When you first think of quantum mechanics, you think, oh, so this whole classical mechanics. No, that's there and this is also there. They were still able to absorb it into their model. And why did it work so well? Because there were plenty of things to be discovered and they were all simple things. Why do you see phases of the moon? If you see phases of the moon and you also see the moons of Venus, then you will realize that the earth goes around the sun and the moon goes around the earth. There is no other explanation for the phases of the moon. So although it may seem to us sitting on the earth that the sun starts in the east and goes to the west, it looks like the sun is moving around the earth. But Galileo showed that using this experiment, there can be no other explanation. That is the essence of reductionism. In a proper way, if you take ancient Indian thought streams, it was based on holism. And analysis and synthesis were subtly intermixed. You cannot have only synthesis or only analysis. If you do only synthesis, you will get black magic. And if you do only analysis, you will not. Because the problem is when you analyze things, when they say analysis and synthesis, the key to Western science, the way of doing it, is to take some phenomenon, split it up into small bits. That is analysis. Then you take the small bits and try to put them all back, then you get synthesis. As long as there is a one-to-one correspondence, as long as the little things are good models for the big thing, then this system works. So all their success stories are things of this type. What happens in actual fact when we get into slightly different things is that when you try to put these little things together, you don't get that big thing. What does that mean? It means that in the process of splitting this thing down, you have lost some essential information. It is not a matter of detail that you have lost. You have lost some essential information. That X factor. And since you don't have that X factor, when you do the process of synthesis, you don't get. Like I can give you a modern example in drug design. You have a protein. And then you have a little drug which is a small molecule which is sitting in the active site. Now, when the little drug molecule sits in the active site, it does so because of a combination of forces and interactions between the big protein and the little molecule. Now, in the computer, I can take that little molecule and take it out very far away. And then with the computer, I'll try to bring it back. Now, if you understood everything about those interactions and you have parameterized your software properly, then the taking out and putting back, I should be able to come back. This experiment, when computer experiment, when it is done, it only works in 70% of the cases. In fully 30% of the cases, the drug molecule doesn't come back correctly into the active site. So it means this is what I mean. The whole is more than the sum of the parts. Essentially, that is the dilemma that scientific problems started facing. So, this is a brief introduction to reductionism. Now I want to come into the Indian thought streams. I will give you 3 case studies. The first I call structure and property. And this subtitle for that, also known as insufficiency of reductionism. Structure and property, insufficiency of reductionism. Next, intellect and intuition. This would be the inadequacy of reductionism. So first is insufficiency. Second is inadequacy. And the third is complicated and complex. This is the most serious. It is actually the total inability of reductionism to solve a problem. So 3 stages हैं यहाँ. Insufficiency of reductionism, inadequacy of reductionism, and inability of reductionism. In all these 3 cases, you find that Indian thought, Bharatiya thought, will come into place very admirably. And this is why our ancients scored many gains in developing these things. They are highly clever people. They knew exactly what they are doing. It would be another talk to give you some of the examples of where Indian science scored in the old days, but let us take it phenomenologically. Insufficiency of reductionism, structure, property. A key of reductionist thinking is if you know the structure of something, you know its property. So, what it is and what it does is exactly corresponding. And this is again true. I mean, you throw Galileo threw that thing from the Tower of Pisa, it landed down. So, you are able to dissect something, that analysis part, structure, and property, the synthesis part, one-to-one correspond. Now it is found today that structure and property may not agree so well all the time. Sometimes different structures have the same property. Sometimes the same structure has different properties. So how do you rationalize all these things? Different structure has the same property. Let's take an example of that from the life sciences. It's called homology modeling. Proteins consists of, big complicated molecules made up of little bits called amino acids, like a thread. So a protein has a function in living systems. It is found that when two different proteins, they have some critical number of amino acids in common, the same location, that is called homology, then the function of the protein is exactly the same. So up to 60-65% it can all be different. The function is still the same. So it is, this is the different structure, same property. Now how does this work? Why does it work? It is because some portions of the amino acid chain are more critical for the function than others. So it's not as clear as it would be. If I can make a gentle statement in front of Professor Joshi, the whole science and art and beauty of winning elections, sir, is that in the first past the post model that we have, when the percentage of votes comes between 30% and 40%, then suddenly the number of seats that you win goes up tremendously. So there's a non-linearity in that. With homology modeling, same story. 30% may the whole functions, properties will all be different. By the time it gets to 40%, it will be exactly behaving the same. So it's a question of non-linearity. How do you address non-linearity? There is a question. Computers alone may not be able to solve some of these problems. What somebody said, what we need, sir, are not faster computers but faster minds. This is what is missing. And when Western methods of reductionism have failed in many problems, now you realize a need to have other ways of thinking. So this is that. Now let us go to the next topic, intellect and intuition, the inadequacy of reductionism. Now in the first part, it is just insufficient. Sometimes it works, sometimes it doesn't work. So that is now we get to inadequacy. Now there are two ways in which deeper thought proceeds, and this is what philosophers comment about extensively. So you have intellect driven thought. This is the Western system. So you read and read and read and read and you absorb all the facts and figures. And once you have all the facts, then you are able to derive exactly what happens in some situation. So once again, cause and effect are clearly connected if you base your entire system on just intellect. And intellect leads to hardcore reductionism. Now, on the other hand, the Indian systems of philosophy were not scared to think of intuitive thinking. What is intuitive thinking? I think it is summarized by many people, but one of the best readable versions is Radhakrishnan's book on the idealist view of life. So taking from Shankara's idea of monism, and let us go to that particular theory, there comes a certain non-linearity in the deeper movements of thought when suddenly from going from intellect you make a jump, an intuitive jump towards the correct answer. So it is not that, intellectual thinking demands a considerable amount of, intuitive thinking demands a considerable amount of intellectual knowledge. You have to read plenty. You should know all the facts and figures. But suddenly there comes a point where all that is not enough and suddenly you have to make that jump. And this jump happens unconsciously. Now, a very familiar example is the Ramanujam is more divine. It goes even beyond intuition.
But it is.
It is his intuition, but although Ramanujan I don't think can be described in philosophy books. I don't think even Radhakrishnan could have described Ramanujan. They were good friends, incidentally, I am told.
There is the limit of it.
There is a limit. Correct. Now, let me give you this most wonderful example from my own subject. So far, I have not talked about chemistry. So, अभी chemistry में भी तो एक example देना पड़ेगा. So, I will give this example. This is probably one of the greatest chemical discoveries ever made in the world. And this is Mendeleev's discovery of the periodic table. Now, what is beautiful about this is that for some years, starting around 1860, chemists all over the world had realized that the properties of the elements had something to do with their weight. They were not exactly sure what it was. But certain properties seemed to be repeating mysteriously. If you wrote all the elements down in the order of their weight, the 8th one looked like the first, the 9th one looked like the second, 10th one looked like the third, and so on. So they found that there were some relationships between these elements. Why it should be and all that, but they saw that some relationship is there. Then they kept on putting more and more and more things. And after some time they found the relationships vanished. And they could determine weights very well in 1860. They could weigh things very proper. That's the only thing they could do. They couldn't do anything else except take something, burn something, weigh something. They did that very well. So they got these atomic weights, and then the chemists all over the world were thinking. This was the holy grail of chemistry around 1860. Then comes this crazy man, Dmitri Mendeleev. Far away, he was somewhere in Siberia, I am told. He used to run a cheese farm, quite a wealthy fellow. And he was doing chemistry for fun, spare time. So he started all these things and started lining all these elements down. I believe he wrote them all on playing cards, the names of the elements. And he used to play patience with those cards and trying to see what the pattern is. He said there is a pattern somewhere, there is a pattern, but it's not coming out. And then he had this intuitive flash. Because he started putting these cards, that is structure, because he was putting them according to weights. Then the property was not matching after some time, as I said. So then what he did, he took the cards and put them under the properties, not according to the weights. Then he suddenly realized one thing. What it meant was that somewhere where the properties were not matching and then he matched the property, some empty space is coming, no? He said that empty space corresponds to an element that has not yet been discovered. So he said, my model is perfect. Something has not been discovered out here. And so I'm going to leave a gap. Then he went further than that. The most important example is the story of aluminium and gallium. So aluminium is a well-known element. There was one gap below aluminium. And then he said an element will be found which looks somewhat like aluminium and it will have this property. This will be its density. This will be the color of its oxide. This will be the color of its sulfate. He made all those predictions. And he was a big Sanskrit buff because in those days Sanskrit was a big thing in Northern Europe. So he called aluminium, below aluminium he called Eka aluminium. And similarly in silicon he put one Eka silicon. Now then what happened after a few years? So he said that this is how it is. And see, this is totally allergic to the Western way of doing science. He is saying that some data will be found which will prove my model. Professor Joshi, I ask you, will anybody, if you send something like that to a journal today, will they accept all these things? Abhi data aayega, future mein, and it will fit my model. Okay, so then what is this going to? What is the proof of his thing? One fellow in France called Lecoq, he actually found gallium after some time. And he did all these things, and then he wrote one letter to Mendeleev. Dear Professor Mendeleev, I think I've got this element that you have mentioned. But you have made a small mistake. The density of gallium which you have given in your prediction is not like that. It is slightly less than that. So he gave him that new density. So Mendeleev wrote, Dear Mr. Lecoq, your experiment is wrong, go and do it again. That means he knew what that thing should be. And Radhakrishnan says in the idealist view of life, he says if the essence of intellectual thinking is communicability, then the essence of intuitive thinking is certainty. You are sure that that is what it is. Then Lecoq goes and does the experiment, and then he wrote one very humble letter to Mendeleev. I have purified my sample and the density comes like what you have said. So, okay. The whole matter was... So, see, this is not very far from our Mahavakyas. When you say Tattvam Asi or when you say Aham Brahmasmi, at that moment, sir, ladies and gentlemen, Mendeleev is actually gallium. There is no difference between him and gallium there. That's it. That is the essence of intuitive thinking. And that, ladies and gentlemen, is unique to this Bharatvarsha. It is nowhere else. And see, after this, the story goes on. Jayantji has mentioned so many things about Nobel Puraskars and all that. Professor Mendeleev never got that Nobel Puraskar. Even though he lived for 6, 7, 8 long years after the Nobel Prizes started. So according to them, it was not just white skin and dark skin. They said that you might have got the right answer, but you got it in the wrong way, so you know. They are not even willing to accept this new way of thinking. That is the motto of the story. And you see, it is... I always say, there was another chap in Germany called Lothar Meyer who was still struggling with those atomic weights and not getting the answer. Lothar Meyer was there and then Mendeleev got the right answer. I always say, and now this will come to the next topic which I would like to address, the civilizational divide. Lothar Meyer could not have got the right answer because he was a German. He comes from the country of Kant, who lived in Königsberg, in northern Germany. Mendeleev came from Russia in Petersburg. The civilizational divide comes there. Somewhere between Königsberg and Petersburg is where this civilizational divide comes. Civilizational divides are extremely significant because we are fundamentally different in different civilizations. Today, Vladimir Putin says that Russia has simply wasted its time since the time of Peter the Great, thinking that we are part of the Western civilization. He said we are not. He says we are a Eurasian civilization. And anybody who has visited the Soviet Union, which I am sure many of us have at many stages, will simply see when you go to that, it was Soviet Union, then Russia today, you will simply see the vast diversity, and if they don't even look like white people in some cases. So when you say civilizational divide, this civilizational divide, ladies and gentlemen, is fundamental. It is got to do with our way of thinking itself. The very thought across different civilizations are different. If we try to deny all these things, sir, then we cannot make progress in science. Because I tell you, Americans are best at being Americans. Germans are best at being Germans. Indians are not best at trying to become Americans. Indians are best at being Indians. And indeed, doing science and all that, The modern problem, Mendeleev problem periodic table was contemporary to his time and era. He could solve it with this methodology. He got the answer. And you see, this is a fundamental, and I think this is something we have to incorporate. Finally, let us take complicated and complex. Now it is a total inability and breakdown of the reductionist way of doing things. What is complicated and what is complex? Simple example I'll give you from roads. Suppose you take 5-6 roads, which is very common in Bangalore, at least I don't see it here. Come and meet in one circle. Then there is one traffic lights at each where the road comes to the circle. So you are there in a taxi or an auto or your car or something. So you go on waiting. Until ever so often you will get one traffic light coming in your favor, 2 cars will go through. This is something all of us have experienced all the time in that kind of system. That is the example of a complicated system, because in any complicated system, if there is a small breakdown, the whole system breaks down. So for example, if one of those lights goes off among those 6 lights, then there is full chaos in that junction. Nobody knows what to do, and they all start running here and there and trying to break the rules. Or suppose all go off because of a malfunction in power, which is very common in Karnataka today. Now all go off. Then what happens? The complex system, on the other hand, is some of these intersections and flyovers which you see today. Big things that look like jalebis from the sky. Starting with the US Cloverleaf crossing from the autobahns and all that. So when you have these system of roads, no car ever stops. Everything keeps moving all the time. So complex systems are like that. They are not designed to break down so easily. A complex system is self-healing. And a complicated system can break down very easily. So if you take a complicated system, how do you solve the problems of a complicated system? By putting in redundancies. Suppose I have a lab with 10 students and I need to do a particular work which requires 10 students. Very often, some student will go away, he'll fall sick or she will say something else. So I overcompensate and take 13, 14 students and put them on the project, knowing that some of them will not be there. That is what is called redundancy. India was a beautifully working complex system by the 7th or 8th century AD. Everything was moving like that intersection of roads and everybody was doing that thing. Everybody knew what they wanted to do. Gradually, with some of the things that Jayantji said, we went from a working complex system to an unworking complicated system. We tried to start putting in redundancies. Swami Vivekananda says, the problems of India are very complicated. He used the correct word, complicated. He didn't say complex. So complicated though it means it is, and then you have got to go on putting redundancies. In the modern political context, the biggest breakdown in our complex system came with partition. So suddenly we have to put in redundancies. What the redundancies we put? All that Article 25, Article 20, all those things that we have done, no, from 25 to 30. Those are our redundancies that we have put in to try to solve that original breakdown. And the redundancies that we have put in are not enough to solve that problem. So you can't go on putting amendments, sir. You can't go on, and somehow hope that it won't fix itself. Partition, let me say, is the fundamental issue that came and hit our civilization. And all of us have to somehow realize that, because it was a civilizational break. A civilization needs land. It is only defined by geography. You cannot dream up some civilization by sitting in Toronto or Nebraska or some strange place like that. We lost the plains of the Indus. Essentially, they have gone out of our collective memory. And the challenge for us today is to somehow And as I said, this civilization, the thinking is different across civilizational boundaries. These are the issues, sir, which have to be put into textbooks, put into curricula, put into various systems to get little children to understand it in a simple way from the earliest point. I can just go on and on. I mean, systems biology, supramolecular chemistry. Suppose you take Jyotish, Ashtavarga. Normally in simple Jyotish, you will say one planet is an enemy of another planet. So suppose you say traditionally Sun and Saturn are arch enemies. So if the two are glaring at each other in a horoscope, too bad for that person who has got that combination. But in the Ashtavarga system, they say you can't simply say that Sun is an enemy of Saturn. They say the Sun is influenced by 7 other planets. So which could either make that Sun stronger or weaker. Similarly, Saturn is influenced by 7 others. So everything influences everything. So in such a scenario, when you put something like this, that is a complex system. And we had Ashtavarga in place from way back. This is nothing some new thing which somebody has started now. So wherever you go and wherever you find fractals, monsoon, cancer, why is cancer and type 2 diabetes different from other diseases? Being a complex system, it heals itself. Heals means heals for its own benefit. It kills the person. But whatever drug you put, that disease will circumvent the drug and go somewhere else. So you see, this is really what is happening. And I would say that in this kind of a scenario, when the reductionist thinking is shown to be insufficient, inadequate and unable to solve the problems, there is a real big need for us to radically, sort of bring our Indian ways of thinking. You can call it Hindu way, you can call Bharatiya way, it doesn't matter, it's all fighting about words. And bring it back, sir, in the syllabuses, Professor Joshi, million thanks for doing what you did with some of those textbooks when you were the HRD minister. अभी ये तो नहीं हो रहा है. And करने दो, sir, let them do. But the thing is, what the whole question nation is asking is, how fast, like chemistry is always about kinetics and thermodynamics. Do you go for the best solution or the fastest solution? In the modern world, I'm sorry to say, Jayanji, it is only the fastest solution which people have to take now. And I've said it a million times in talks. Better to be somewhat right on most occasions than to be fully right on 1 or 2 occasions only. That somewhat right is actually what this country needs today. It needs it in our education policy. It needs it very, very badly. And somehow we have to bring the urgency of all this. Try to bring in our whole setup and try to refashion. This is, both strategy and methodology are needed. Strategy is what to do. Methodology is how to do it.
Yes.
And these are independent. If you start mixing strategy and methodology, you get into great trouble. You get into very, very big trouble. And before I finish off, I'll just do if you'll excuse me, Atharva people, little sales gimmick. I've completed a book which is called Bharat India 2.0, and this will be released on 15th August 2022, or 75th year of our independence. And this traces a structural chemist who is supposed to be quite well known in his subject. What's he doing? Writing about the Indian Constitution. So I have written this book. In fact, this afternoon I went to my publishers and it's in the very final stages. So the book is going to come out, and it has to do with our Constitution, why it was written the way it was written, the limitations that those had, what we have done with the Constitution in 75 years, the fact that there are some very, very basic flaws in that document. So I hope that you people, ladies and gentlemen, you enjoyed what I'm saying, but go there and buy that book. It's coming out.
Discount for the audience today.
Oh, yeah.